All right, so the reason that you need to do the parent functions before this is because it's important to know the general shape of the parent functions as we start looking into these piecewise functions. So if I say, what does an x squared function look like, a squaring function, you should be able to, in your mind, picture a parabola. Or if I say, what does a square root function look like, you should be able to picture that little kind of half curve, almost half of a parabola on its side. So those are the things you kind of want to be thinking about as we're doing these problems. And let's see. These all day, of course, as soon as I start talking. Okay. The first thing we're going to talk about with a piecewise function is how to evaluate a piecewise function and what it means when you see these little x less than, x greater than stuff. So you're going to have different pieces. Most of the ones you do are going to have 2 pieces, but they could have multiple, 3, 4, 5 pieces to them. And it's really important to focus on the domain that's listed to the right. And they're all going to be, this won't be interval notation, it'll be our less than, greater than symbols. This domain tells us when do we use that piece. So if I have x squared, if x is less than 1, that means I only use that piece if I have an x value smaller than 1. So 0, -1, -7, +1/2, any of those values would get plugged into this piece. At the bottom, I only use this piece, my linear part, if my x is greater than or equal to 1. So 1, 2, 3, 4, all of those get plugged into the bottom piece. Hello. Both. Both. Okay. All right, so this is function f of x, f of -2. We've seen that before. It means plug -2 into the function. When it's a piecewise function, though, you just have to figure out which piece do you plug it into, because it's one or the other, but not both. So -2, according to my domains that are listed, would I plug it in the top piece or the bottom piece? It would go into the top piece because that is an x value smaller than 1. So I would just do -2 squared. And my answer would be what? 4. That's it. Okay. F of 3. Would 3 go into the top piece or the bottom piece? It would go into the bottom because it is a number greater than or equal to 1. So I would do 2 times 3 plus 1, which gives me 7. Make sense? Okay. Graphing a piecewise function. The x squared function will only show up where x values are less than 1. So it's going to show up on the left side of the graph. The 2x plus 1, which will make a line, so y equals mx plus b, is going to show up for values greater than 1. So it's going to show up on the right. When we make our table, we're going to do half of our points for the first piece and half of our points for the second piece. So we're going to try to organize this a little bit. So for the first 3 points, I'm just going to use the top piece, which is y equals x squared. I'm just going to put y instead of f of x. For the bottom 3 points, I'm going to use my other piece, which is y equals 2x plus 1. Now remember, we're not allowed to just choose any x values we want. They have to be within the domain that that piece is described for. So y equals x squared is described for all x values smaller than 1. So like -1, 0. I'm also going to put 1 in this table because I can get really close to 1, but I can't touch 1. So I'm going to make a note to myself that that's going to be an open circle. Okay, if we do not include 1 in the table, you miss all the values between 0 and 1. Your piece won't be long enough. So we're going to include 1 in the table where we consider it like a breaking point, but we're going to put an open circle there, which means we know that we can't equal that number. And then y equals 2x plus 1, the bottom piece, can be any x value greater than or equal to 1. So I'm going to put 1, 2, 3. And for that one, where the breaking point is, I'm going to put a closed circle just to remind myself I am allowed to equal that point. That's where x is defined for 1. Okay? Does that make sense? All right, so now all you have to do is plug those x values into their respective equations. So the top 3 are going to get plugged into x squared. The bottom 3 are going to get plugged into 2x plus 1. So -1 squared gives me 1. 0 squared, 0. 1 squared. Okay, and then the bottom 3 get plugged into 2x plus 1. So 2 times 1 plus 1. 2 times 2 plus 1. 2 times 3 plus 1. We did that one already. It was 7. Okay, so now let's plot these points. -1, +1. 0, 0, and then 1, 1 is an open circle, meaning we're going to get really close to that point but not touch it. We know that y equals x squared makes what shape? We know it's going to be a parabola shape, but we're only going to see part of the parabola to the left of 1. So we're going to connect our dots, and we know it's going to continue indefinitely all the way to the left. Okay. My other 3 points, 1, 3, close circle, 2, 5, 3, 7, and that's just a y equals mx plus b equation, so that's going to make a line. That piece was only defined for x values greater than or equal to 1, so it's all the numbers from 1 and then extend it forever to the right is what that tells us. So we're going to have a line going to the right, and that is the graph of your piecewise function. Okay, so it takes a little bit of time to set up the table, but if you set up your table correctly, it all just kind of falls into place after that. So you want to take your time with that portion of it. Any questions before we try another one? All right, let's go to the next one on your sheet. We've got g of x equals -3 absolute value of x, and that one's defined for x values less than or equal to 0, and then square root of x if x is greater than 0. So let's start by just evaluating a couple. G of -5. Will that get plugged into the top piece or the bottom piece? Yep, we're going to look at those domains. It is a number less than or equal to 0, so it's going to be -3 times the absolute value of -5. What's the absolute value of -5? 5 times -3 is -15. Okay. G of 16, is that getting plugged into the top piece or the bottom piece? It's getting plugged into the bottom because it is a number greater than 0. So square root of 16 gives me 4. And we don't worry about pluses or minuses when we graph a square root function because then it wouldn't be a function. It wouldn't pass our vertical line test. Okay, so let's look at that table now. Let's split it into 2 pieces. Top half for the top piece, bottom half for the bottom piece. My top half is going to be the graph of y equals -3 absolute value x. My bottom will be y equals square root x. What's the breaking point? What's the number that separates the 2 pieces here? The last problem, it was 1. That's what separated the 2 pieces. That was our breaking point. What's the breaking point in this problem? 0. I'm going to put 0 in the middle of my table. I'm going to put it there twice. For the top piece, is 0 defined? Am I allowed to equal 0? Yes. So I'm going to put a little closed dot there. For the bottom piece, am I allowed to equal 0? No. So I'm going to put an open circle, meaning we're going to get really close to that number, but we're not going to touch it. All right. What other numbers can I plug into the top piece? Go ahead. Sure. -2 and -1. Anything less than 0 would work. And then what numbers can I plug into the bottom piece? Anything bigger than 0, right? And don't pick numbers that are difficult, like square root 2. We probably don't want to do that, right? So like 1 I could pick. What would be another easy number to graph if I took the square root of it? 4. Work smarter, not harder there, right? Okay. So if I plug -2 into that top equation, what do I get? -6. If I plug -1 into that top equation, what do we get? -3. If we plug 0 in, we get 0. Plug 0 in the bottom equation, what do you get? 0. Plug 1 in, we get 1. Plug 4 in, we get 2. Table's filled out. Okay, let's graph the first 3 points. -2, -6. -2, -6 down there. -1, -3, and then 0, 0 is a closed dot. Do you guys remember from yesterday what the shape of an absolute value graph looks like? It's a V shape. Now this one's upside down because there was a negative in front of it. And again, we're only seeing half of the shape. So from 0, and then everywhere to the left, there's half of my v. So it's going to look like a line on this one. What does the square root graph look like? Like this. Right? It starts at the origin, and then it just kind of curves up slowly to the right. Yeah. Okay. Now this is interesting. 0, 0 is also on the second graph, but it's an open circle. So you're going to have an open circle on top of a closed circle. If you were to hand that to somebody, they would not know which one is closed and which one is open. They would just look at the equation to figure out that. Now, you cannot have 2 points on top of each other, which technically we do not. 2 points on top of each other would not pass the vertical line test because they'd be on the same vertical line. When you have an open circle and a closed circle on the same vertical line, there's truly only 1 point there. So this is okay. 1, 1 is my next point. 4, 2. And then we know that guy's defined for all values greater than 0, so it's going to go forever to the right. Now your paper has an extra question at the bottom. It says, is it continuous, or something to this manner, at 0? Something like that, right? That means, is there a break in the graph at 0? There's not a break in the graph at 0, so we would say that yes, this is continuous. If you can trace the whole piecewise function without picking up your pencil, you have a continuous graph. Now let's look at the one before. Can I trace that whole graph without picking up my pencil? So we would say that this is not continuous, if you want to label it. That way you have an example of each on your notes. Okay, so if you can trace the whole thing without picking up your pencil, it is continuous. If there is a break in your graph, it is not continuous. Okay. Questions there? In the graph of piecewise function, evaluating piecewise functions. All right, most of the ones that you guys do in Math Excel will just be matching for the graphs. So you might not have to go through the whole table procedure for it. You might just be able to read the equation and say, okay, I know to the left it's going to look like an absolute value, and on the right it's going to look like a square root, and it breaks apart at 1, so it's got to be this function below. You can maybe save yourself a little bit of time if you recognize those things on Math Excel. All right, the last 2 problems are from Math Excel. So you will see these on your homework. They might not be these exact same numbers, but they will be similar. A couple of the problems are going to ask you to write the function for the piecewise function. So we're going to call this piecewise function. You can name it whatever you want, I guess, right now. They'll tell you in Math Excel what to name it. We're going to name it f of x. How many pieces are here in this picture? More than that. There are 3 pieces. So what you're going to need to do is write 3 equations. And then you're going to have 3 domains that each equation shows up on the graph within. I'm going to try to color code this and number it for you. I'm going to start with the easiest one. The easiest one, I'm going to call number 1, is the horizontal line in the middle. That's a horizontal line at what number? Y equals what? Y equals 2. Now remember, f of x means y, so we already have the y equals. All you have to do for the middle piece is put 2, because it is a horizontal line at 2. What numbers does that horizontal line show up between? What x values? 0 on the left. This guy right here is when x equals 0, and then it goes all the way to 2 on the right. So that's my domain. My x is going to be between 0 and 2, and we're going to put this in our inequality notation. So x in the middle, the smaller number on the left, the bigger number on the right. Inequality symbols should always point in the same direction at the smaller number. So they're both going to be less than symbols there. And then I have to, if I have any solid dots, add the little line underneath. At 2, there is a solid dot, so that second inequality sign is going to be equal to. The first one is not equal to because I have an open circle. All right, that's my middle piece done. Let's look at the piece on the left. That's just a regular old line, we're assuming. So 2 things you need to write the equation of the line. What are they? What two things do you need to write equation of a line? You need slope and one more thing. Come on, guys. Yep. Perfect. You need a slope and a y-intercept. Do I have the y-intercept in this picture where it is touching the y-axis? Yes, it is touching the y-axis at 0. Well, it's an open circle there, but if we extended that line, it would touch at 0. So y-intercept is 0. The slope I do not have, but I can find it from the picture, right? I can just count my rise over run. Should this be a negative slope or a positive slope? It's going to be a negative slope, right? Because my line's going down from left to right. So you can just count how far do I have to fall? And how far do I have to run to the right? You have to go down 2 and right 1. So my slope is -2 over 1. Now, if you didn't want to count it, you have 2 points. You have -1, 2, and you have 0, 0. You could use those 2 points and do your slope formula, y minus y over x minus x. I have a slope. I have a y-intercept, which means I can write the line. Your first piece is y equals, which we already have the y equals, -2x. And then if you want to say plus 0, you can, but you know you don't need that there. What two x values does that piece show up between? -1 and 0. So -1 less than x less than 0. Are either of those equal to? -1 is equal to. Good. Because I have a solid dot at -1. Great. Okay. Third piece, we do not have the slope and we do not have the y-intercept. But we do have 2 points on the line. We have 2, 2, and what's the other point on that line? 6, 0. Okay, if you have 2 points, what's the first thing you can do? Find the slope using your slope formula. Y minus y, 0 minus 2. X minus x, 6 minus 2. I get -2 over +4. My slope is -1/2. I'm going to fill that in my piece. -1/2 is going to be in front of my x. I am still missing the y-intercept. So what did we do before? If we were missing the y-intercept, we went to our y equals mx plus b. We filled our slope in for m. And then we filled one of the points in for x and y. You can use either point. Anybody have a preference? 2, 2. So x is 2, y is 2. And then you can solve for b. -1/2 times 2 gives me -1 plus b, which means b is 3. That's the rest of my equation. -1/2 x plus 3. What piece does that, or what domain does that piece fall within? From what number to what number on my x's? 2 to 6. 6 is an open circle. 2 is a closed circle. Now here's where it gets a little tricky, and Math Excel will accept multiple answers. We already said that this 2 up here was equal. That's where the 2 is defined, which means this one cannot be equal. If both of those are equal, it means you have 2 points on top of each other, which means technically it does not pass the vertical line test because there's 2 points on the same vertical line. So if you have this continuous situation where there's really not a break, one piece is equal, the other is not, it doesn't matter which one. You do not know from the given information. Some of the Math Excel problems, the inequality signs will already be filled in for you. You're just going to select the one that has the correct inequality symbol, so it'll be either one or the other, and then you'll fill in your equations from there. Okay, so again, if you have this one not equal to and this one equal to, that would also be a correct answer if you're just writing it from scratch. Okay, questions on that one? There's a lot of work in that one. Okay, last problem of the day. It says this piecewise function will have a break at x equals 3, except when a is equal to what value? So we don't want it to have a break. We want it to be continuous. which means at 3, we want them to be the same thing. When I plug in 3 to either piece, I get the same point. That happened on that first, which was it? Second one on the first page, right? If I plug that number in, I got the same point, 0, 0 for both of them. That's what made it continuous. So let's plug in 3 to the bottom piece first, because there's no A there. If I plug 3 in, I get 12, which means the point 3, 12 is on this graph, or the open circle, 3, 12 is on this graph. Which means the top piece, when I plug 3 in, I also want to equal 12. That will ensure that there is not a break in the graph, that those two pieces intersect at the point 3, 12. So now you can solve for A. 3 squared, make sure you square before you multiply, so it's going to be 9 times 2 gives me 18 minus A. Subtract 18, negative A equals negative 6. A is 6. Final answer. If A is 6 and you plug in 3, you get the same answer for both pieces. So that makes it continuous. There's no break. Alrighty, that's it for 2-6. Okay, so you guys have 20 minutes now to work on your Math Excel. The 2-6 Math Excel is due tomorrow night by midnight. So work in class today. Ask me questions if you have them now. Tomorrow, if you have any more questions, we'll go through them together. It'll be due tomorrow night. All right, and I'll do the cell phone lotto for you.